Welcome back to the Scotti-BYTE channel, and this is Scott. So I run both IPv4 and IPv6 on my main LAN, as well as on a few of my VLANs. And there's a consideration for users that run Windows, and so I've entitled this one Windows DHCP and Local DNS. And what prompted me to do this was my tutorial about NginX Proxy Manager and Local DNS, where we learned that Pihole can be a local DNS, and in conjunction with NginX Proxy Manager, it can provide local network SSL certificates and also a way to be able to get to your sites via SSL if your internet connection is down. So in a dual IPv6 IPv4 network configuration, both Windows 10 and Windows 11 prioritize IPv6 traffic over IPv4 traffic, and it even prioritizes IPv6 DNS servers before the IPv4 DNS servers. So Microsoft says they're following RFC 3484 for the prioritization of IP traffic. I find it interesting that the author of RFC 3484 happens to be Microsoft. This has unintended results for Windows users who have not properly configured their IPv6, and that's one of the things that we're going to review in this tutorial. So what exactly does this do? Well, typical home networks use DHCP servers to grant private addresses. And when individual systems are granted DHCP addresses, the DHCP servers also provide other types of information. And one of the other things it provides are the DNS addresses for the DNS servers to use. And if you haven't made any changes to these, then it's using your ISP's DHCP servers. And if you have made changes, you're probably using Google, or you're using Cloudflare or one of the other domain name service providers to resolve your domains. It's also possible to use local domain name servers, and Pihole is one of those local domain name servers. And that previous video that I mentioned goes into the detail of how to make it work for local DNS translation. So if you use both IPv4 on your network and IPv6, the IPv6 prefix allocation and the DHCP version 6 server addresses come from your ISP, just like I mentioned that they do on IPv4 by default. So we're all used to changing IPv4 configurations on our routers in terms of perhaps DNS addresses, DHCP scope, and other things. But we don't pay a lot of attention to that configuration for IPv6. So DHCP version 6 provided DNS servers come from your ISP, as I mentioned earlier. Your router IPv6 configuration can also manually specify DHCP version 6 servers, and they can be pointed to your Pihole just like you pointed your IPv4 to your Pihole. So this will allow the Pihole to operate as a local DNS for Windows, since there's no reasonable way that I found to force Windows to use the IPv4 name server addresses before their IPv6 name server addresses. And again, if you only run IPv4, you won't have this problem, but if you also run IPv6, that's when you're likely to run into this issue. So this is the preferred solution, since changing the IPv6 prefix policies and making registry changes, which are two things I found documented out on the internet, they typically provide a way to make some of these changes, but they also result in unintended changes in your IPv4 and IPv6 processing. So what I'm going to suggest is a much better and also safer way to do this. So Windows will not let you prioritize IPv4 DNS servers before IPv6 DNS servers, unlike Linux. So let's go see how this works. So this video is all about the oddities that you may experience if you have both IPv4 and IPv6 enabled on your network at the same time, which is a typical configuration, but not a common configuration. So in my case, I have a Ubiquiti Unified Dream Machine Pro, and you can see that at the top end I have IPv4 enabled using DHCP and IPv6 connection type using DHCP version 6. One of the differences is that your DHCP4 server normally comes from your router and is located on your router. Your DHCP version 6 server is usually upstream from your router at your internet service provider. And in this case, I'm using prefix delegation, which is the normal methodology. And I say, give me a 56-bit delegation size because with my ISP this works. Typically, you're going to have a delegation size that's somewhere between 56 and 64, and you should contact your ISP to find out exactly what that needs to be. Now that we've verified that IPv6 is configured at the WAN level, then we also have to have it configured at the LAN level. So in this particular case, we're not going to focus on the configuration of IPv4 or IPv6. We're going to focus in specifically on the DHCP name servers or the DNS servers. So on most routers, they have a section where you can specify your DHCP name server. If it's set to auto, then what happens is it gets the DHCP name servers from your internet service provider and it fills those in. Since we want local DNS resolution to take place, we set this value to manual, and in my case, I have 172.16.1.6 set as the local DNS server, which is a Pihole, and then my secondary and tertiary addresses here are for Cloudflare. If we move on down the screen, we see that we have IPv6 options. I've enabled IPv6 on this LAN because I have prefix delegation set up, which goes ahead and gets me an address pool from the WAN interface, and the IPv6 DHCP server at my ISP provides those IPv6 global addresses to my local LAN connections. But further down the page, you'll notice that DHCP v6 is set to auto right now, and just like with DHCP 6 DNS servers or DHCP 4 DNS servers, when we have it set to auto, it gets those values from the ISP. The same thing is true of having the DHCP v6 servers set to auto. It will get the DNS servers for IPv6 from the ISP. In looking at my Ubuntu desktop, my physical device is ENP4S0, but since I use LXD on my desktop, I've set up a bridge called Bridge 0, which I've discussed on the channel many times before. So in doing an if config, you can see that Bridge 0 has an IPv4 address of 172.16.1.225, and because the bridge is performing many different functions, it has 4 different IPv6 addresses, and these are IPv6 global addresses. So we also have an FE80, which is a IPv6 local link level address. And then we have a couple of more global addresses down here, along with, of course, the hardware MAC address for the particular controller device, which in this case, Bridge 0 is virtual, so that's a virtual MAC address. Further examining this Ubuntu desktop, I can cat out the /etc/host file, and you can see that the only thing in the host file are the loopback connectors. However, I can do an NS lookup for things like my Rocket Chat server, and it will come back and give me the address of my Rocket Chat server, and it will be accessing 172.16.1.6 as my local DNS server, which is the Pihole. Likewise, I can also do an NS lookup of things like google.com, and google.com will be upstream from the Pihole, and it will come back and give me several IPv4 addresses for google.com, and it will also give me several IPv6 addresses for google.com, since I have both IPv4 and IPv6 enabled at my desktop as well as on my network. The way we solve this problem is I SSH'd over to my Pihole, where I will do an ifconfig command. And looking down here, you can see that the IPv6 global address of my Pihole ends in B13C. So I'm going to copy that address, and I'm going to go down to the DHCP and set it to manual for DHCP6, and I'm going to paste the DHCP6 address for the Pihole in the first field. And then I'm going to go out to the second field of the DHCP DNS server listing, and I will paste in 2606:4700:1111, which is the Cloudflare DNS address for Cloudflare's primary server. And then I'm going to paste in the same address ending in 1001 for Cloudflare's secondary server. If you're wondering why the IPv6 address is so long, is because 2 consecutive colons mean that the fields that are intervening all have zeros, and you're allowed to pad that with a : to indicate as such. So in Windows 11, if I do an ipconfig/all, you can see that I'm running both IPv4 and IPv6, since I have an IPv4 address and a few IPv6 global addresses. And my DHCP server is 172.16.0.1, which is my router, and it's also my default gateway. However, my DNS server, my primary DNS server, begins with 2601 and ends in a 1, which is an address for my ISP, which means that DNS server is located at my ISP. And that's the one that gets searched first. And then the secondary address is 172.16.1.6, which is my local Pihole server. So if you remember from my video, NginX Proxy Manager and Local DNS, one of the things that we did was we could do an NS lookup of Rocket Chat, and for whatever reason, we have to end that with a period in Windows in order to get a proper lookup, and it comes back and says that it went to that address and it got the translation of Rocket Chat as a local address 192.168.80.229. We know this isn't true because it had to go to 1.6 to get that address. But this is really one of the interesting and odd things about how Windows 11 is working. Now if I do an NS lookup of chat.scotti-BYTE.com, if in fact we were looking at the Pihole at 172.16.1.6, that would translate to a local address, but it does not. It returns my WAN address instead. So now I've gone back and I've updated my router to have the IPv6 addresses for my local Pihole, and you would think that this would solve the problem. So I would have to do an ipconfig/renew, and I've also done a reboot. And then you would think that if I did an ipconfig/all, that it would list the IPv6 address of my Pihole, which does not start with a 2601 and end in a 1. So this is really interesting, because then if I go into Control Panel and I go into Network and Sharing Center and I click on my Ethernet interface and I go to Properties and I go down to IPv6 and I go to Properties there, it says it's obtaining an IPv6 address automatically, which it is, and it says it's obtaining the DNS server address automatically, which you would think that it would, but in this case, since I have my router set to manually designate those addresses, it should have picked up those addresses, but it did not. So now I have to say, use the following DNS server addresses, which by the way, I believe is a bug in Windows, because it should have gotten the IPv6 override addresses I gave for these servers in the router, but it did not. So we'll go back here and we will designate these two addresses, the first one being the Pihole ending in B13C, and the second one being a Cloudflare address. I click OK, I click Close here, I click Close here, and I close this as well. And at this point, if I do an ipconfig/all, we are not going to see the new address, or we did. Actually, it surprises me, because I would have thought we had to do an ipconfig/renew, but since we didn't, and we changed the adapter instead, it's updated here. Now what's interesting is we can still do properly the NS lookup of rocket chat dot, and it will come back and find the correct local address, but we can also do an NS lookup of chat.scotti-BYTE.com, and now this should not bring back my WAN address, but instead this should bring back the address of my NginX Proxy Manager, which ends in 215. And you can see that that is what it has done. So Windows to me seems a bit inconsistent, but this is the workaround to get it to operate properly. And now if we do an NS lookup for google.com, you'll see that it does touch the Pihole at B13, but the Pihole correctly accesses the upstream servers and goes back and returns IPv6 addresses for google.com, and also it returns one IPv4 address for google.com. This verifies that our Windows machine out on our IPv4 IPv6 network is communicating with both IPv4 and IPv6, and more importantly, it's actually able to resolve IPv4 and IPv6 addresses. The key point in all of this is that unfortunately there doesn't seem to be any way to change Windows to look at an IPv4 DNS server because it always prefers looking at an IPv6 DNS server first. But the workaround was to provide the IPv6 address of our Pihole, and now DNS resolution is working for the local network as well as the upstream servers out on the net. So in summary, IPv6 is here to stay, and dual IPv4, IPv6 networks are becoming much more common. It's important to configure your IPv6 on your router if you have enabled IPv6. We discovered that Windows prioritizes IPv6 DNS servers before IPv4 DNS servers. Pihole will configure IPv4 and IPv6 by default at installation time. We saw how to configure DHCP version 6 DNS servers with the IPv6 address of the Pihole to allow Windows to resolve local DNS names. Anyway, that's it for today. Please subscribe and like the channel, and don't forget to hit that notification bell, and we'll see you next time.